Okay, now we're cooking with gas. Minimize that. Close that. Too many tabs open. Too many tabs open. All right, let's take a 10 minutes in here real fast. See what we got going on. Done. I know Maddie's here. I saw her earlier. She said hi this morning. That row's here. That row's here. Maddie Pummel. And Sarah is back there. So we're just missing Maddie Pummel. All right. Weekends. You guys have no energy. How can you guys always be so energyless almost?
It's Monday.
It's like this every day. Oh, there's Yusef. He wants in. That's why you're supposed to go to YouTube Live instead of my Zoom meeting, you doofus. All right. See, I'm going towards bad mood. I'm heading there.
Is it because of the Super Bowl?
No, that's not what it's about at all. It's because people like Yusef keep going to my Zoom meeting instead of YouTube Live. Big gypsy. All right. We are going to talk about weekends now. We are going to start with none other than Savannah Vickers. That's all you did? Did you have any good snacks during that? Very nice. Sarah?
I was with my friend all weekend. We got up at like 6:30 in the morning to go to Caesar's Creek and watch the sunrise.
To go see what?
To go to Caesar's Creek and watch the sunrise.
Cool. Was that Saturday morning?
Sunday morning.
Was it a pretty sunrise?
It was.
Did you get some pictures of it?
I think I got a video.
Video? Very cool. Very nice. Ali!
Saturday, I applied for finance and I have a new car, and Sunday we watched football at Super Bowl.
All righty. Sounds good. Lundgren!
I baked some cookies.
What kind?
Chocolate chip.
From scratch?
From
Bacon break?
yeah.
They are an amazing thing. How many did you eat raw?
Like 2,
Uh-huh.
maybe.
Uh-huh.
On Saturday, I worked 10 hours with no break, and then,
And no pay?
well, I got paid.
Oh, okay.
Hopefully, it's paid.
Yeah,
And
maybe
then-
you never know.
Sunday, I watched the Super Bowl.
All right. Davening.
Friends came over to celebrate my brother's birthday.
How old's your brother?
He is 17.
7. Does he go here?
Yeah.
Really? Who's he got this year
I don't know.
for math class?
I don't know.
You know what he's taking?
I don't remember that either.
Okay. You know his name?
Liam. Wait, my brother?
Yeah.
Liam.
Okay. Good. Wanted to make sure you remembered that. We're okay, Davening. It's okay. No problem. Chloe.
I guess I didn't do anything.
That's okay. Nothing wrong with not doing something, you know, taking a weekend off and just chilling. That can be good for the body. Timothy.
On Sunday, I got out with friends, kind of drove around and walked around at Meyer, which I mean, it's better than nothing.
Yeah, I mean, I can spend time doing that sometimes. Okay. Rachel.
Sectionals for tonight.
Heard that went well.
Yes, it did.
Good. So now 2 weeks till districts?
Yep.
Very cool. Lane.
Baseball and watch the Super Bowl.
Baseball and watch the Super Bowl. Hamza.
I went to my friend's birthday party, the same one that Tom was talking about.
What? So is that your friend? Really? You know his name too?
Yep.
You can remind Donovan if you forget it, okay? All right, thanks. Alexander.
I got new gaming headphones because my old ones were messing up, and I started actually broadcasting my gameplays.
Nice. All right. Well, hey, let's take a look at these problems and see how we did. I'm going to just work all these out. See how it went. Wait a second. I changed my mind. Hold on. Clear off your desk. Hey, Yusuf. You hear me, Yusuf?
Yeah, I hear you.
You're going to want to go to the Google Classroom. I'm going to give you a quiz. You're going to have 5 minutes to finish it, okay?
Okay.
All right. I almost forgot.
Todd just told me last week.
How did I go?
Yeah, baby. Woo! Oh, yeah. Okay. Let's put it. Oh, let's see here. Kami for him. He's doing it on the Kami assignment. You guys are going to get a hard copy of it. Shaboobity doo. Blop. All students? I don't think so. I just want to give this to, where's he at? Yusuf. One student. Okay. And let's do this. Boobity doo. And let's see here. Here, it's due today. And I'm going to give it to him in a few minutes. He's going to have 5 minutes to do it. That's it. Love it. Actually, he's going to have until 12 noon to do it. Okay. Beautiful. Let's get you guys going. It's going to be coming your way in a second, Yusuf.
How do I know if you're taking the pop quiz?
I don't know. No calculators. Don't need them. Yeah.
Hey, you did everything on my desk.
He just isn't on the right with. 5 minutes. All right.
We read our names where he says listening.
Yes. Okay, it's coming your way, Yusuf. Booyah! Go get it, Yusuf. When you're finishing, just flip it over on your desk. All right, Youssef, we're going to start going over the worksheet from Friday. Hopefully you're ready for that, Youssef.
Yeah, I'm ready.
Here we go. Let's do these. So I'm just going to work my way from top to bottom. So I'm just going to actually start with number 6, since it's the highest one up here. So nice thing about this, I just have a logarithm. This is a nice, neat old logarithm. I'm just going to switch it to exponential form, and that would be 10 to the 12 equals 4t. So then t would be 10 to the 12 divided by 4, and you could leave it like that, and I would be happy, happy, schmappy, wacky. Okay? There's number 6, done. All righty? Next one, number 2. So number 2 is just exponential form. Just change it to a logarithm. This would be log base 3 of 17 equals x. So we started off nice and neat here. Just started off with just changing forms is basically all we're doing on those 2 problems there. All right, number 8. Again, it's a logarithm. It's isolated. It's all by itself with the number on the other side. So I can rewrite it as an exponent. So I could write this as 10 to the 1/2 power equals x plus 3. Subtract 3, so you could write x equals 10 to the 1/2 power minus 3, or you could write the square root of 10 minus 3. Either one of those would be completely fine. They're the same. Number 4. All right, so number 4 is exponential, but the base with the exponent, it's not by itself. So my first step is to get 10 to the t plus 12 isolated by itself. Okay. So 10 to the t plus 12 equals, yes, you got it. It is what? 45. Great. There it is. Now it's in exponential form. Rewrite it as a logarithm. So this would be log, common log. I'm not even going to write base 10. It's the common log of 45 equals t plus 12, which means that t would be equal to the common log of 45 minus 12. That's number 4. And then I'll do 10, and then if you have any questions, I'll take care of them. All right, 10 is the first one on here where you have multiple logarithms on the same side of the equation. So my first step here is I want to condense this. I want to condense into a single logarithm. So I'm adding 2 logarithms of the same base. I can rewrite as the product property, the logarithm of a product. So it's going to be the common log of, and when I multiply these, I'm going to get t squared plus 3t equals 1. All right, so I just took this t and distributed it through here. Now I can write it in exponential form. 10 to the first power, 10, equals t squared plus 3t. Get everything on one side. So t squared plus 3t minus 10 equals 0. And factor if you can. T plus 5 minus 2. So my solutions then are t equals -5 and t equals 2, but we always check. So -5, no way, Jose. Can't take logarithms of negative numbers, so that's extraneous. And then 2 works here and here, so that is the good one. So anything you want to ask about the first side? Anything at all? No? Nobody has any questions? I mean, that's not a bad thing, if you're honest about it. All righty. Let's check out the math. Boop. Number 11. All right. So number 11, again, I have 2 logarithms of the same base being added. So I can condense those by using the product property. So this is going to be log base 2 of, I'm going to multiply it out, t squared minus 1, and that's going to be equal to 5. Go to exponential form. 2 to the 5th equals t squared minus 1, which means that 32 is equal to t squared minus 1, which means that t squared is equal to 33. And now it's the square root of both sides, or to the 1/2 power, and I only want the positive root. If I put a negative root up here, I'm going to have a negative logarithm. Not going to work. So my answer is the square root of 33, okay, or 33 to the 1/2 power for those daring individuals out there. All right, that's number 11. Number 16. Let's go purple on this one. I'm feeling purplish. Oh, I feel purplish. All right. So this time, it's different. I have multiple logarithms, same base, but they're on opposite sides of the equation. I want them on one side of the equation so I can condense them. So I'm going to choose to add log base 2 of 2, and I think that's really a plus x, no, it's minus x. I'm going to do that to both sides. So on the left-hand side, I get log base 2 of negative x plus log base 2 of 2 minus x, and that's equal to 3. Now my logarithms are on one side, so I can actually condense them into a single logarithm. So that's going to be log base 2 of, I'm going to multiply, so I'm going to get x squared minus 2x equals 3. Go exponential on it. 2 to the 3rd equals x squared minus 2x. So here we've got 8 equals x squared minus 2x, which means x squared minus 2x minus 8 equals 0. Then if I factor it, I get x minus 4, x plus 2 equals 0. So my solutions are x equals 4 and x equals negative 2. And then I look back at the original equation. 4. What do you think of that? That would be log base 2 of negative 4. No good. Toss it. Negative 2. Yep, log base 2 of 2. And this would be log base 2 of 4. I like them. Answer is x equals negative 2. Okay? We're doing good, right? Hopefully. You guys. There's no energy in here. Make you guys do wind sprints or something. All right. Number 14. Again, I've got multiple logarithms on the left. Same base. This time, no, they're not being added, they're being subtracted. So it's not product property, it is the quotient property. So I condense these, and I get log base 2 of t plus 1 over t minus 1, and that is equal to 3. Go exponential on it. 2 to the 3rd equals t plus 1 over t minus 1. So 8 is equal to t plus 1 over t minus 1. What do I do to solve this? I don't like having t minus 1 in the denominator. What do? Multiply both sides by t minus 1. Cancel uni. Distribute. 8t minus 8 equals t plus 1. So I'm going to subtract a t and add an 8. Subtract the t and add an 8. Do two things at once. It's amazing. 7t equals 9. So t equals 9 sevenths. And if I look back here, that's fine there. It gives me a positive. And even here, it gives me back a positive. So I'm happy with it. Looks good to me. Now we haven't done the extra one yet. All right. Before I even talk about the extra, anything you want to ask about on either side of the problems that were there, that we just did, or that I just did? No? All right, so here's what you're going to do for me on the front. You're going to flip to the front where your name is, right? There's a 1, 10. Okay, on a scale of 1 to 10, I'm going to ask where you are. Here's what this means. Scale of 1 means I don't even know where Mr. Snyder's room is yet. A scale of 10, that would mean that you could teach the class the rest of the period and tell people how to do all the problems. So 1, you're lucky if you can find this room. 10, you can teach the class and I can take the rest of the day off. Tell me where you are on your paper. I want to come around and just look. I want to get an idea. So this is between just you and I. Okay. 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 All right. Okay. All right. All right. No one's teaching today. That's okay. Mine. I want to teach. Okay. So let's go ahead. And you know what? If where we're at right now is what you guys are telling me, there's no reason to even do the extra problem right now. Because that's probably above what you understand somewhat in some ways. And that's not a criticism. It's just like, hey, let's spend our time better looking at the ones that are the other type of problems. Okay. So what I want to do right now then is the following on the front. Okay. I would like for everyone on the front to do number 9 at this point in time. Let's just do a fresh problem, number 9. Okay. Dun, 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 dun. Boom. Dun, 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 dun. Shoot, doop, doop, wah. Dun, dun, doo. Let's write this. That's really a plus sign. All right. First step. Anybody willing to volunteer first step? Hamza. Condense it? Yeah, I can condense the right-hand side. All right. So when I do that, I'm going to take the 2 and the 3 plus x and multiply. So I get 6 plus 2x. Make sure you distribute it through. Now do what? Now that I've got a single logarithm set equal to a value. Do what? Yeah, go exponential on it. So that would be 4 to the first power equals 6 plus 2x. 4 equals 6 plus 2x. Subtract 6. So we get negative 2 equals 2x, so x equals negative 1. Is that okay to have x equal to negative 1 in this problem? Look back. Is that okay? Yeah, because it gives me what inside? A positive value. That is completely fine. So my answer is right there. X equals negative 1. We okay with that one? We're good. No questions. It's just so quiet. All right, on the back, let's try number 12. Try number 12 in the back. What time we got here? 27. That would be good. This will take us to that time roughly. Dun, doo, 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 bitty, ba. Hmm. Do, do, do. Um, Okay, right-hand side condense the right-hand side. So I get negative 2 equals common log of what?
2 over 3 plus x.
Great, 2 over 3 plus x. All right, it's a logarithm now. So now I go exponential on it. 10 to the negative 2 equals 2 over 3 plus x. 10 to the negative 2. What does that equal to? What's that? I could write it that way if I wanted, 0.01. I'm going to actually write it as a fraction. There's a reason. This would be 1 over, because since the right-hand side's a fraction, I want the left-hand side to be a fraction. It's proportion now. In solving proportions, you do what? What do you do to solve a proportion? Yeah, cross multiply. Okay, the cross products have to be equal. So you're going to get what? 3 plus x has to be equal to 200. Subtract 3, x equals 197. Ka-chow. There it is. Okay. All right. It's break time. Isn't it? No, it's not. We got time. We got oodles of time. Anybody have a question on that one? Blah, blah, blah. No. I'm not getting any feedback. Feedback on the top of the sheets is not matching the feedback now unless you guys all of a sudden have mastered this. 17 and 18, we're not going to worry about those right now either. We'll talk about those later, maybe tomorrow. So well, let's do this. Here, let me give you the new one. And all we're doing today is we're going to be working on more. Yes, we do have one more thing we can talk about. Well, a couple things. One is just applying this to word problems now and solving them. Okay, if I want an exact answer. And then the other thing, we do have one other part too. So with the time we have, would everybody just please do number 1? You should be able to get number 1 done before you leave. I think Yusef, you should be looking online. There was something posted at 9:30 a.m. called Extra Exp and Log Equations. That's what you got to be looking at.
Yeah, okay.
We're doing number 1. Number 1.
Okay.
Okay. We got it? Number 1? Well, there we go. I thought I just opened it up. There it is. It's on the wrong page. Okay, number 1, 2 logarithms of the same base are equal. It's the top over there. If log base b of x equals log base b of y, then what? X equals? Then all I have to do here is say what?
X plus 2 equals 8.
Oh my goodness. Boom, got it. There was number 1. Okay, there it is. Great. Now, I'm going to tell you which problems, got a second here, which ones I want you to start doing when you come back. When you come back, would you please do number 2, 4, 5, 7, and 8. 2, 4, 5, 7, and 8. When you come back, you guys take your break. Okay. Then we're going to go over those, see how they went. After I give you some time to work on them. Then I'm going to give you some off the back to do for homework tonight as well. Right. So today is going to be practicing, getting help as you need it along the way. And don't wait until the bus is way down the road and then call me for help to come back. Okay. While I can still see you in the rearview mirror is the time to call me. Shut up. Da, ba, da. Okay. When? Hey, you go. Yeah, let's leave. Ooh, I love it.
Something like a quiz.
Yeah.
Can you try that in the second to last one?
This one here?
Probably super easy, super easy
This?
way, but yeah.
X to what? X to some power of 1. What? Just there's an exponent that you can use that always gives you back 1. Anything to the power of. If I wrote this in exponential form, it would be this. Okay, so here we go. What has to go there? Here's the first power is 2.
Yeah.
Here's the second power is 4.
Now it's X.
Okay, you ready? Here we go. Can you tell me what the answer to this is? Do as an exponent. What would this be as an exponent?
Like,
Okay, here, let's do this. Let's use variables. What is this equal to as a number? It's x to the 5th over x to the 5th. Anything over itself in a fraction is what? 1. Okay, now, when you have two bases that are the same being divided, what do you get the exponents? So what would you get here? X to 0 power. Something to the power of 0 is 1. Doesn't matter what this base is. It can be anything you want. The answer is always 0. Because what power do you have to raise a number in order to get back 1? 0. One. Zero power of x is 1. Like that is what's this as a logarithm?
1 base X.
Touch it, how?
Okay.
That's it.
All right.
Okay.
Thank you.
Yep. Let's check. See if there's anything interesting going on there.
I'll tell you all about my fabulous swimming.
Oh yeah,
My
how
mind.
go?
Yeah, we did a really good first relay. The boys, apparently the boys, like they didn't do bad, but like it's usually supposed to be all like crazy. And it wasn't.
Yeah.
For the boys, like they weren't getting hyped up enough. As it should have been. And so we got all quiet and girls. And so the girls were like, we gotta get like, gotta get hyped. Like, and they got hyped up. It was super good. Team Ed was great. Nice. Nice. That one we're going to distancing. We're going to distancing all the relays. So the thing is, all the relays have the same people on them.
Yeah.
Just in different orders. So it's like,
Wait, which order are you usually on?
Ryan the medley and then the anchor. Wait. Ryan the medley.
But like, are you first, second, third?
That's third. And then the anchor and the 2-3 and then the 4-3.
So you're the anchor?
Surprises. Nothing surprises team, but I sort of played team between like point scoring. I'll probably get MVP.
Nice.
Probably, hopefully. If not, then Joe. And then I don't know. After that, I had a fabulous 100 fly. I got second. Almost beat a girl that went to state. But she was kind of out of it, so.
Yeah.
That was good. What was after that? The 2-3, by far the worst relay. That's because everybody just went, like literally everybody.
How long have they been?
Like 2 hours.
What time do you go? Like at what in the morning?
Ours was in the morning, Saturday morning.
Yeah.
It's not like morning, it was like 8. Too free. We don't discuss too free. It was a little meh. And then the fourth one, this is where I was at. Like, I don't know what happened, like what drugs everybody was on. Literally
And it
all
was-
3 of them. But okay, so the vote at first went a 101, which is better than she didn't do what she had done. She spent 100 for earlier as an individual, not a third what she had done. She was doing it individually.
Yeah.
So that was good. And then the second person that won had just swum 100 breaths. The order is the same that every single one of them. It's 100 breaths is right before the first relay. And she swam, went at 59. She usually goes like 1 or 2, so that was really good. Yeah. But Hannah, you know Hannah, she went next. And she's never gone under a minute before. She goes a 58.9. And then I go, and I've been under a minute one time. It was like a 59.8, and I go 57.1.
Whoa.
And so for the first time in like 5 years, our fourth relay was under 4 minutes.
It's super exciting.
It was. And that one even made it. We didn't think that was the one we didn't think was going to make it. Was the fourth grade.
Yeah.
And that one actually made it better than the 2th grade did. The 2nd is where it's at for us. And we have like specialty swimmers like Joe only really does breaststroke. I really only do fly. Lots of specifics. And then Hannah, that's a good like Hannah. The reason she's not interested as an individual is because she's not fast enough in one event. Like she's just overall like decent, not just like decent everything, but then like super good at just one event. Yeah. So I kind of feel bad for her, and we can't take any alternates this year. No alternates.
What's that?
So like, if you take alternates for a relay, like in case someone gets sick or something like that, they can't even come to the meet. Like you used to be able to staff alternates for every single relay so that you could bring more kids.
Yeah.
But this year they said no.
What happens if someone's gone and you're just like this one?
No, you just pull someone else in. Like we have an automatic alternate because the crowd keeps going. So if one of us injures ourselves at the meet, then like they'll just bring someone else that's there. So,
All right, so let's go. Do. Guys, I didn't tell you at the top, it says to round all decimals. I want you to find it both exact and then practice on your calculator finding logs too. Okay, I'm sorry, I should have told you that. At the top, nearest 10,000, so you're going to find it exact, and then you're going to go ahead and give it to me to the nearest 10,000. Go. Yep. That's why you're stuck. My guess is, huh? What? What'd you have? What's the step before that? What was that? Where's your, you can probably put the worksheet. Yeah. Hold on. This is number 10. Look what's wrong with this. Look what you ended up with. What are you missing? You think that's kind of important, isn't it? A little bit. Just a tad. Tad bit of importance in that. Close that. There we go. Close that. That's good. Close that. Close this. Ciao. Yes, okay. Do. Let's plug that if we get everything on. We got inside. We're going to set equals 0 and try to find the zeros of it. Wait till you get set equals 0 and play factor. Okay. So you have to get set equals 0 first, and then factor. Because the whole reason we do that. Are we multiplying two things together? Getting 0, I know that one of these has to be 0. Either that is or this is true. Because anything times 0 equals 0, right? So if you have a product of 0, you know you have to have a factor of 0. I have a product of 6. My factors can be 1 and 6, 2 and 3, 6, 7, 7, 7, 4. So there's numbers are 7, and there's all kinds of things. So that's why you have to have it set equal to 0 for that technique to work. Okay. Now this one, because here it's right. Great. This is
Yeah, that's right. So, that's good. Today's little one?
Yeah.
Change this to exponential form. What would you get? Tell me, what would you get? Spaces are the same, so are the exponents. So what's the answer? Yeah. Now, this base and this base, this is an inverse of this. G to the power log base P, log base G's are inverses. If you take the log base G of G, these are inverses. This is always going to give you one. Okay, so that's why equals 2. And this one here, can you do this for me? Can you tell me what that equals? X to the 4 over X to the 4. What's it equal as far as an exponent goes? X to the 4 minus 4, which is X to the, so X to the 0 equals 1. Write this as a logarithm. Log is X of 0 equals log base X of 1, and then it equals 0. Here's your answer, that's 0. The only way you can erase something to the power of that 1 is if you don't make this face as if you raise it to the power of 0. Anything to the 0 power is 1. Okay. And then these two will get the same way. It's the whole inverse function thing. You have to write this as a logarithm. It's log base b and a question mark equals the exponent. Same logs. And I'm asking for that. This is 12. Value. I don't know what you mean. I'm not sure what you're saying. Where did you see these problems at? You're asking about. Okay. So we're talking about something that might look like this. Is 2 of 16. Evaluate that. Okay. So here's where you have to get this base and this base the same. 16 is 2 times 2 times 2 times 2. 2, 4, 8, 16. So it's equal to 2 to the 1. So then this is log base 2 of 2 to the 4. And these do what? Cancel each other out. That, yeah, that was why. That's why. Okay. You trust me. You're fine. How's your doing here? I want you to go back and fix this one. Okay? Keep going. You're good. I'm going to go ahead and I'm just going to write the answers up here. I'm not going to do the work. You can check yours, and then I'll tell you which ones in the back I'm going to ask you to do as well. So I'm going to put some answers up here. Like this.
Okay. So those are the ones I asked you to do in the front. Any of those you want to? I'm gonna leave this up here on the back. I'm asking you to do the following problems in the back. 9, 11, 13, 14, and 15. And if you don't get them finished, you can just finish those for tonight.
Mr. Sanders,
Yeah.
can we do number 2?
I sure will. 1 second, and I'll be right up there to do it. Did you say number 2?
Yes.
Okay. Let's take a look at number 2, if you need it. Okay, so I've got 2 logarithms that are in the same base. So my goal, if I have a situation like this, I just want to set these values equal, but I have this -2 tagging along here. So what I want to do is I want to use the power property. So the left is log base 4 of x to the -2 equals log base 4 of 9. So now I can say x to the -2 equals 9. How do I solve this? Raise this to the -1/2 power. Okay, now think about what this is saying. This is 9 to the -1 raised to the 1/2 power. What's 9 to the -1? What happens when you do that?
1 over 9.
It's 1 over 9. So it's nothing more than 1 over 9, and the 1/2 power is what root? It's the square root. Just take the square root of the top, square root of the bottom, and you're done. And I don't want it to be negative because I can't have a negative x value there. Yeah. 7? Yeah. Let me make sure people have that one written down, then I'll do 7 in about a minute. You okay with number 2? Is that still? Seven. Okay, number 7. What I'd like these to be base 5. I'd like them to have the same base. 25 is 5 squared. So I can rewrite this as 5 squared to the 2x power equals 5 to the x squared minus 12 power. However, power property, on the left, I get 5 to the 4x equals 5 to the x squared minus 12. Now I can just set the exponents equal. So I get 4x equals x squared minus 12, which means x squared minus 4x minus 12 equals 0. Just move the 4x to the other side, make it minus. And then factor it. X minus 6, x plus 2. So the solutions are x equals 6 and x equals negative 2. And both solutions are okay because it's an exponent. I can have positive and negative exponents. Okay. Yeah. 8? Yep. You bet. All right. Condense log base 6 of x times x, x squared, plus 4x plus 3x plus 7x plus 12 equals 1. Exponential. Go exponential on it. 6 to the first power equals x squared plus 7x plus 12. So that means 6 equals x squared plus 7x plus 12, which means x squared plus 7x plus 6 equals 0. And then it's just factored. X plus 6, x plus 1, x equals negative 6. And then when you look at them, negative 6 does not work. It gives you back negative logarithms. So I have to get rid of that one. So x equals negative 1 is the only one that works and gives me back positives inside. Okay. Anybody else want one on the front? Yeah.
I have a real quick question about
Number 2, yeah.
So how did the 9 to the negative 1 half power become 9 to the negative 1 power?
Because I using the power of the power property in reverse. Reversing it. Because you can't take negative square roots. I know the 1/2 power is the square root. So in order for me to do this, I need to get rid of this negative exponent. So I could have just said this. 9 to the negative 1/2 is 1 over 9 to the positive 1/2. I could have just thought of it that way. Because the rule is x to the negative 1 is 1 over x, or x to the negative b is 1 over x to the positive b. That's one of our laws of exponents. So if I get to this part here, 1/2 power is the same as the square root. It's 1 over radical 9. That's where that comes from. Okay? Yep, you bet. Okay, so you're doing those problems on the back. And then tomorrow, we're just going to start off tomorrow going right over those. And I will tell you, there is no quiz tomorrow, so don't flip out. You're not going to come in and get another quiz tomorrow. Okay. Tomorrow, though, I want those done so we can go over them right away. And we're going to probably just do some extras, and then we're going to start doing some word problems where you're going to solve them algebraically as well. So what you were doing before in graphing to get answers, you're now going to solve and get answers. You're going to solve them algebraically to get exact answers and not decimals necessarily. Yusuf must have gotten kicked out. He wanted back in. Yusuf, you must have gotten kicked out, bud. I'm sorry.
It's fine. I just got kicked out a couple minutes ago.
Well, you must have gotten kicked out, bud. Sorry. I do not like that delay. I hate it. Ah! Okay. This. Maybe later. Yeah. You're right there. Condensed. Left and condensed more. Now look at the board. If log base b of x equals log base b of y, then x equals y. Yeah, that's it. That's all that. It's a proportion. So I wonder what did happen to Maddie today. this. Good. All right.